Hello, welcome back. Today in this installment we will be talking about Chapter 8, or rather Chapter 9, Propositional Logic and Propositional Logic Translations. So as we said before, there are two very common types of deductive logic, and we already covered categorical logic, so now we're going to go ahead and start talking about propositional logic. So propositional logic doesn't deal with classes and categories like categorical logic did, nor does it deal with terms in the way that categorical logic did. But when it comes to translating premises and propositional units, we'll be abbreviating whole ideas, sometimes containing both subjects and predicates, by using single letters, usually lowercase in this case. Or we could use uppercase as well, it doesn't really matter, just stay kind of uniform with it. So what is a proposition? A proposition, again, is kind of just any type of statement, right? And a proposition can have something that's called a truth value. Right? And any proposition can have one of two truth values. Either it's true or it's false. So when we talk about truth values, that's what we're talking. Is a proposition true or is a proposition false? All right? And that's going to play a lot into what we're going to be doing in this chapter and even more into next chapter. So propositional logic will look very different compared to categorical logic. It will look very mathematical. There will be a few symbols known as operators that I'm going to introduce in a little bit here, which will have their own meaning. And these operators each correspond to a certain logical relation. M and K present four logical relations. However, I'm going to add a fifth one that's also important. So the following, these are the relations, right? And they each have their own symbol. A lot of people call propositional logic symbolic logic as well because you use a lot of symbols. So the first one is negation. Okay, let me actually get that in the front there. Which is often, this means not, right? And it's symbolized with a tilde. There's the symbols that I'm going to teach you, other books may use different symbolizations, but we're going to use the ones. The tilde, that is the kind of the little thing that goes over the ña in Spanish, or like piñata. So this is often indicated by words like not, false, no way, wrong, or incorrect. So essentially, negation works in such a way, right, that it reverses the truth value of a given proposition. You can kind of think of it kind of like a negative sign in math, right? So if propositional unit A is true, if you add the negation sign, that makes it false, and vice versa. So we will pretty much just translate all negations as not. So, something like this, we would just say not A. All right, and remember that will change the truth value of A depending on what truth value has been assigned to A anyway. Okay, the next one is going to be, so this is conjunction. Okay, these will read as and statements. And these will be symbolized by the dots. Like I said, other texts will maybe say use an ampersand. I like the dot. Dot is good. So conjunction combines two propositional units. So like I said, we generally read it as and, but when you're looking at something and translating it, it can be indicated by words like and, but, although, however, as well as, also, etc. So a conjunction says that both parts that form it are independently true. So essentially, if we see something like this, we read that as A and B. And the implicit assumption is that both A and B are true. That'll come into play a lot more a bit later here, but we will get there slowly but surely. The next one I want to talk about is called a disjunction. These are what we would call OR statements, and they'll be represented by the wedge. Looks like a little v, essentially. Actually, when I type them, I just do use lowercase v. So this phrase says that at least one or two propositional units are true. So we'll refer to them as OR statements, and usually OR is really the only thing, either or, something like that. So something like this will read A or B. And remember, with OR, the implicit assumption is that at least one is true, possibly both. Okay? The fourth is the conditional. These are if-then statements, right? They form some type of condition that needs to be met. If it is raining, then I will get wet, or something like that. So conditional propositions indicate a certain type of relationship between propositional units. It says that if one of the propositions is true, then the next one will be. We'll discuss this a little bit more in depth, as this particular one can get a bit tricky, but like I said, this is what we call an if-then statement, and we'll use what's known as the horseshoe. Kind of just looks like a sideways U to represent it, and it's written like this. So this means if A, then B, right? So whatever comes before the horseshoe is the if part, and after is the then part. So if A, then B. All right? And the last one, M and K don't talk about this one. It's not used all that much, but it is used, and I think it's important that you guys know it. It's called equivalence. And this is kind of self-explanatory, right? It signifies that two propositional units are equal. So that means if one is true, the other one is also true. If one has a false truth value, then the other one also has a false value. So I guess, something like equals would be the kind of buzzword that you may see, or is equivalent to, or is the same as. And it's represented by the three lines. It's kind of like an equal sign with an extra line. Like I said, this isn't one that you see too often. It's used a lot more in the higher order logic type stuff, which is a bit above our heads, which we also note that these are all what are known as operators, all these, right? So go ahead and go through in the book, M&K's book, pages 236 to 241. They'll provide some extra assistance for translation, and it's really vital. It's important stuff. You're going to be doing some translations, a little bit more than you did with the categorical stuff, because translations here are very important. So I'm going to take a second just to talk about translations. Remember, in categorical logic, there's only really so many things from our English language that we could really express with this. Well, propositional logic will allow us to express a lot more thoughts, and thoughts that are a lot more common, or I guess that make more sense with the way that we talk, right? So that's why this is going to be very important. Translating will also be very important as well. So I want you to go ahead, also as just a practice thing, I won't grade it, but to practice translated, the selected propositions for 9.1, and those are, I believe they're indicated by a star. The answers in the back of the book. Practice translating those and check the answers in the back of the book so that you get some practice on it. One of the things that you'll see, essentially, I'll say a couple more words about translations than just what M and K have there. You'll see a lot of things in narrative form, and I'll still be asking you to put things in logical form. But what we're going to be doing here right, is we're going to take things in narrative form, and we're going to give certain propositional units their own single letter abbreviation, right? So something like if I have a beard, then I am a man, right? We would say, okay, having a beard, let's call that B, and being a man, we'll call that M, and therefore we'll say, if B, then M, right? If I have a beard, then then I am a man. Things like that. And we're going to come up with arguments. And some of these statements, though, may be a little bit more complex than just this. All right? So some statements will be of the nature of, let's say I say something like, let's say if I have a beard and, I don't know, muscles. Then I am a man. Okay, so here let's use, so B will equal beard. We'll just say U will equal muscles. And M will equal man. Well, here we can see that we have an and here, right, which will indicate a conjunction, right? But we also have an if-then, which is the larger statement that the conjunction is a part of. So to translate something like this, we would have to say B and U, then M. And we'll put parentheses here, right? And again, this is a lot like math, a lot like algebra, which, if you've taken it. Parentheses will kind of say that these things go first, right? Or something along those lines. And then from parentheses, you can get more complex and have brackets. Go ahead and read in MNK, right, on pages 241 to 244. Read a little bit more about what they say about brackets and parentheses. And I think the logical order is parentheses, then brackets, then these things, which I always have a hard time drawing and never really know what they're called. And that'll deal with, kind of more complex problems. And we'll kind of get into that slowly, but like I said, essentially pages 236 to 244 in M&K, look over. They're going to help you with translations big time. I don't know if I necessarily have enough time here to really go over translations in depth. Like I said, these are the signal words, not, also in your notes you have some more signal words. I tried to give you those for a couple of things that will signal certain types of operators. And this is generally how they're displayed. And, like I said, you could add complexity by adding parentheses and brackets and things like that. So I'm going to get into something here as well, right? What we're going to be doing here with propositional logic is working on something known as truth tables. Okay, and truth tables, similar to the Venn diagrams that we did in the last unit, truth tables are going to allow us to assess validity for arguments. And so I'm going to show you generally how to do truth tables, and then in the next installment we'll actually go through what truth tables mean and diagram full arguments. But for now, we're just going to diagram certain premises or certain statements and whatnot, certain propositions. So let me go through and show you. So each of these operators, like I said, do something with a truth value, and I'll show you what the truth tables look like for these operators, right? And so remember, like I said, that there are there are two possible truth values for any given proposition. And those are true and false. So a truth table wants to go essentially look at all the propositional units and assess the truth value of a given proposition using the operators based on, in order to do that, they want to see every possible permutation of truth values of any given propositional units, right? So we're going to start with negation. And negation usually only uses one propositional unit. So let's say not P is the statement that we want to assess the truth value of. Well, if P can have one of two truth values. It's either true or it's false, right? So, very poor table. There's negation that we're showing here, right? So this is our propositional unit. These are the possible, right, our propositional unit P. Its possible truth values, either true or false, and then the statement that we're trying to look at, right, not P. Now remember, I said negation works in such a way that it reverses the truth value. So in this case, if P is true, negating it would make it false. And likewise, if P is false, then negating it would make it true. All right? So that's what the truth table for negation looks like, right? Whenever P is true, the negation makes it false. When P is false, then the negation makes it true. All right, I hope that's clear to you. So we're going to go ahead and we're going to move on. So the not, like I said here, the not operator reverses the truth value of the propositional unit. Now in the conjunction, we need two propositional units, which means that we're going to have more rows, right? So let's say we have propositional unit P and propositional unit Q, right? And we want to prove P and Q. Now remember, we have to take into account every possible combination of truth values of P and Q. So there's one situation in which both are true, the situation in which P can be true but Q can be false. There's also a situation where P can be false and Q can be true. And then there's obviously a situation where they can both be false. Right? Again, we're adding extra rows and extra situations because we've added an extra variable. Essentially, whenever you add another propositional unit, so n units, or it's 2 to the n unit, right? So n here equals number of propositional units. So we have 2 propositional units, so 2 squared is 2. If we had 3, we would have to have 8 rows, and so on and so forth. Let's get back to this, right? So, I'll show you what the table looks like, and then I'll talk it out to you. So when P and Q are true, are both true, then this statement is true. Then P and Q is true. When P is true but Q is false, the statement is false. When P is false and Q is true, the statement is false. And when both are false, it's false. Now, remember what I said, one of the implicit kind of assumptions with the conjunction was, one of the implicit assumptions, when you say something, blank and blank, what you're implying is that both of those things are true, right? If you tell, let's say, your wife, I will wash the dishes and I'll vacuum, something like that. Well, when your wife gets home, she's going to expect both the dishes to be washed and the living room to be vacuumed, right? If you do one, it doesn't quite cut it. You need to do both. Both need to be true. If she doesn't want to accuse you of lying, right? So if you say P and Q, in order for that as a statement to be true, both units must be true. All right, so that's why the only time that this is true is when both are true. If both are false, if at least one is false, then the whole statement is false. All right, I hope that's also clear. So now we'll move on to the disjunction. Remember, this is the or statement, right? And again, we only need two propositional units at least, right? Say P or Q. Okay, and remember the same propositional units. All right. Let me get that. All right. Okay, so when P and Q are both true, the statement is true. When P is true but Q is false, the statement is still true. When P is false but Q is true, the statement is still true. But when they're both false, the statement is false. Okay? And let's think a little bit more in depth about this. Remember, this is an or statement, right? So let's say you make somebody a deal, right? You say, listen, I'm going to do one of two things. I'm either going to mow your lawn during the summer, or I'm going to shovel your snow in the winter. Well, what is that other person going to expect out of you? That you do at least one of those two things. If you do both, that's a great bonus, right? But if you do neither, and you promise to do one or the other, well, then you haven't lived up to your promise there, your deal, your end of the bargain. So that's kind of how this works here. When they're both true, that's fine. That's an added bonus, right? You just said one of the two is going to be true, essentially. And that's what an or statement is, right? If you say, I'm either going to have coffee or I'm going to have tea. It's understood that you're going to have one or the other, right? Now, you may end up having both coffee and tea. That's an odd combination, but it's possible, I guess, and that's an added perk. But if you just have coffee, you still said something true, right? But if you just have tea, you still said something true. But if you say, I'm going to have coffee or tea, but you end up having a soda, neither's true. All right? So again, I hope that's kind of clear to you how that works. Remember, it's only false when both units are false. All right? Lastly, not lastly, we have two more left to go, but we're going to spend a lot of time on this next one. This next one seems to give people a lot of trouble. It's the conditional, the if-then, and the truth table maybe doesn't make as much sense as, let's say, the three that we've had so far. So let's go ahead and go through it. The conditional. Remember, this is our if-then statement. Again, we're just going to use two units. Now, like I said, I want you to go through and do some of the practice problems in addition to the homework this week. Those are going to help you out. And the only really way to get through this is to practice. And like I said, to read what M and K have to say on translating and on doing truth tables is going to be huge for you. There's really no other way to get it done other than to do the reading as well. But I'm going to try to help supplement the reading here. So please don't ever take the lectures as something that you could take on your own or just the reading as something on your own. I think you need both to kind of help you out throughout the whole course. But let's get back to this. So again, our truth values are the same as always. So we have a case where they're both true, where the the first is true, where the second is true, and then well, neither are true. So if P, then Q. All right. Well, if they're both true, then the statement is true. Let me actually get through. Let me talk about the structure of this. Right. The if part, right, the part before the horseshoe is what's called an antecedent. That's the condition that needs to be met. All right. That's the condition that the conditional statement is putting forth as something that needs to be met. The second part, the then, the part after the horseshoe, here in this example Q, is what's called the consequent. And it's the consequence if the condition is met, right? So if I say something like, if I get straight A's, then I'll have a 4.0. Well, if I do in fact get straight A's, then the consequent would necessarily follow, right? But if I don't get straight A's, I don't know, a couple different things can happen, right? So we're going to keep that in mind as we go through. But so like I said, if the antecedent and the consequent are true, then the statement is true. Now, if the antecedent is true, but the consequence is false, the statement is false. I'll explain this a little bit more in a second here. If the antecedent is false, but the consequent is true, the statement is true. And if both the antecedent and consequent are false, the statement is true. Okay, and that last one really throws people for a loop. So let's talk this out here a little bit. Like I said, let's say you're a student, which you are, and you say something like, if I get straight A's, then I will get a 4.0. Right? And this isn't taking into account weighted grades or anything like this. Now, if the antecedent is met, which means it's true, you get straight A's and you get a 4.0, right? The consequence is true as well. Well, then you got what you were promised. The condition was met and something followed it. That's exactly how it should work, right? Well, in the next case, right, when the antecedent is true, it's true that you got straight A's, but somehow you didn't get a 4.0, well, something went wrong then, right? Maybe you got swindled a bit. You were promised that if you met a condition, then something else would follow. You met the condition, but it didn't follow. Something's not right there. And that's why this case is false, where the antecedent is true, but the consequent is false. That's why that whole statement is false under those conditions, because you didn't meet, or you didn't receive the consequence that you were promised to a certain extent. Now, let's say it's the case, right, that the antecedent is false. So you didn't get straight A's, but you got a 4.0 anyway. There was some type of glitch in the system or whatnot. Well, that's fine. You ended up with a 4.0. Nothing, I guess it's kind of weird, but it's not like you expected to get the 4.0, right? The fact that you got it is like an added bonus. And here, if you didn't get straight A's and you didn't get a 4.0, well, then the world is working just right as well, right? You didn't meet the condition, right? And so you shouldn't expect the consequence. So nothing weird happened in that situation. The only weird one, right, is where you meet the condition, but the consequence doesn't follow. That means something's wrong with the statement. Let's say if I said, if I'm human, then I'm mortal, right, and I never die. Well, maybe I'm not human or something like that. That could be the case. I don't think that could be the case, but that's why something's wrong with that statement. So I hope that makes a little bit of sense to you. It's definitely different. I think let's go through one more example too, right? So let's say let's say you're a kid, right, and your mother says the following thing to you: if you do your chores, then you can go outside and play. Tempting offer, right? So again, let's consider the first outcome. That you do your chores and your mom lets you go outside and play. Again, nothing weird happened. You did what she asked, and she gave you the reward, right? So that's exactly how it's supposed to work. Now let's say you did your chores, but at the end your mom says, well, you're not allowed outside. Something unfair happened, right? Your mother didn't uphold her end of the bargain. That's why this is a problematic case, right? When you meet the condition, but the consequence doesn't follow. Then the third situation, you don't do your chores, but your mom lets you go outside anyway. Your mom seems like a really nice lady, right? So she never said that you need to do your chores in order to go play, but she just said that if you did them, then you would surely be allowed to go play. Again, added bonus, right? Now, if you didn't do your chores, your mom doesn't let you go outside, you don't really have much of an argument to make, right? Given that you didn't meet the condition, you couldn't have reasonably expected to go outside and play, so there's no loss, right? You didn't uphold your end, so your mom had no obligation to uphold her end, and that's why there's no problematic case. This one's true, all right? And so again, I hope that helped out a little bit more, even more than the last example. I think this is actually a much better example. It's also in your notes. Take a peek at it again. That could help explain why these tables look the way they do. All right, and so lastly, we'll talk about equivalence. Equivalence is really easy. Again, we only really need two for the mock tables that we're doing. So P is equal to or equivalent to Q. Okay? If I say P is equal to Q, that means that they're exactly the same. They're identical, even, right? P is true, Q is true. That's true, because they're identical. P is true, Q is false. False. They're different in that case. P is false, Q is true. Again, false. They're different. Now, P is false and Q is false. Sorry, apologize. That's true, right? They're the same. So, again, whenever the two sides of the equivalency operator have the same truth value, then that operator, that statement is true. Okay. So, truth tables can become really tricky, right? When you have more than 2 units, and I said that before, right? You could have more units than just 1 or 2. You could have 3, and then your tables become larger. Number one, because you have to account for more situations in terms of the truth value of all the variables or propositional units. So that it becomes tricky when you have more than 2 units, and they become very tricky when extended propositions are used, right? And that's kind of like the one I had earlier on the board, where we had a lot of parentheses and bracketing going on. Again, extended propositions are propositions for which you need parentheses, brackets, etc. And the most important thing, right? So when you have an extended proposition, the most important thing is to find the main operator, right? What kind of statement is this extended proposition, right? There may be little ones here and there, but what's the main statement involved? Okay? So we're going to do the example. It's in the notes here. And we're going to have 3 operators and 4 units. So 4 units would require, remember, and you won't really need to do this. I don't think I go above 4 units, but I have in the learning module, I have something called truth table templates. It'll have how many rows you need to have and all the truth values all set up. That way you just kind of make the rest of the table if you want. Because it does get kind of tedious to write down true, 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 false, 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 and all that good stuff. Remember, so if you have, so n equaling number of propositional units, rows then equal n, or 2 for the 2 types of truth values to the n power. So 2 to the 4, or the 4 units we have, equals 16. 16 rows. This one's going to be a bit of a doozy. Alright? But yeah, so I'm going to write this down in a second. Again, the key to extended propositions is finding the main operator. Okay? In order to figure out what the truth value of that main operator is, which would then determine the truth value of the whole statement, we need to figure out the truth values of the other operators as well. So let's go ahead and do this. I'm going to erase the stuff from the board here. Well, you do have it all because they're in the notes. Okay, so here I have the statements A and B or C equals D. So it's either the case that A and B or C equals D. So you could say it's either the case that I love animals and I love bats, or my love for cats is equal to my love for dogs, or something like that. I don't know, that's probably not a very good example. But so we have our 4 propositional units, A, B, C, and D. And the statement that we have is A and B, or C is equivalent to D. Okay. So let's start here. Set up the truth table itself. Okay. So we have a lot of situations going on here. Obviously, I'm not going to explain them all, but you see them. There's obviously the one where all 4 propositions are true, where they're all false, and where they fall in between, right? Now, what we want to do is look at all of these, right? And we need to kind of figure out what the sub-truth values are. I'll use the red marker for this, and I'll use smaller letters, right? So in this situation, A is true, and B is true. And remember, with an AND statement, that makes the whole thing true, right? And here, C is true and D is true, and the equivalency statements, that makes that statement true. Now we have true or true, right? Which we know with the OR statements, given our truth values, would make this whole thing true, right? Now again, A is true and B is true, so that's true. Now here, C is true and D is false. That makes this one false. Still, we have true or false. Statement as a whole is true. Here again, A is true and B is true, so that part is true. C is false and D is true. False. True or false, so true. This situation again, A is true and B is true, which makes that statement true. And here, C is false and D is false. Remember, for the equivalency, that makes that true. We have true or true rather. Remember, true or true. The whole statement is true, right? Remember, this is what I call it. The disjunction here is what I'm calling the main operator for this statement, right? It's the one in the middle that kind of pulls everything together. Okay, in this case, on this row, the fifth row here, A is true but B is false. That makes that statement false. And here, C is true and D is true, so that makes the statement C is equivalent to D true. So now we have false or true. True. Here we have A is true and B is false. That makes A and B false. We have C is false and D, or rather C is true and D is false. That means C is equivalent to D is false. False or false means it's false in that scenario. Now, again, we have A is true, B is false. Makes A and true false. C is false, D is true. That makes C is equivalent to D false. Makes the statement as a whole false. Here we have A is true and B is false, which makes the statement A and B false. And we have C is false here and D is false. C is equivalent to D. False equivalent to false is true. Makes the whole thing true. Okay, and now we can do something really quickly here, right? We know that in order to make this part A and B true, they both need to be true. Well, we see here for the next 8 that A is going to be false. So we know automatically that the left side is false for the next 8 instances, right? So that'll save us a bit of time. Now let's just focus on C and D. True and true is true. True and false is false. False and true is false. False and false is true. True and true is true. True and false is false. False and true is false. And false and false is true. Now let's go through these last 8. False or true. True. False or false. False. False or false. False. False or true. True. False or true. True. False or false. False. False or false. False. False or true. True. Okay, now that was obviously a very long one. It's intense. And it takes some time. These are tedious. These are definitely tedious. But I'm giving you 2 weeks to work on this material. That way you can ask me a lot of questions. You can work on the practice problems. You can do the homework problems. And we can get you guys all set. Like I said, if you're drawing the truth tables out, or printing them out, or one way or another, something that could be helpful is to kind of do a smaller thing, especially for extended propositions. That's what I was trying to do here is, so this true here is corresponding to this statement alone, and this true is corresponding to this statement. Then you can just kind of see, okay, true or true. It makes a lot more sense. You know what I mean? You can kind of go back to your truth table templates for the operators that I put up earlier, and it's easier to kind of determine the truth value of the statement as a whole. So go ahead, like I said, work on the practice problems in the book, the selected problems. I'll give you the homework, and they give you some more selected problems too. I haven't decided on that yet. But work on this stuff. If you don't get it right away, don't feel bad about it. But be sure, pages 236 to 241 in the book, you must read. Bottom line, they will help you a million. Definitely read that stuff. I know MMK can sometimes be a little bit difficult to read, but I think they're pretty good in this situation. So please go ahead and read that stuff, and we will see you next time.